Essentially, we're an interdisciplinary team using technology and collaborative storytelling methods across architecture and emerging media arts as a way to bring in the past and help shape the future. We work between the physical into the digital and vice versa. Currently, we're using LiDAR scans, photogrammetry via drone capture that Rogue out of Kansas City captured. We are also experimenting with NeRFs, neural radiance fields, real-time 3D technologies, in addition to 2D video and images. Essentially, we're trying to create a new language, collage of different storytelling methods.
So you can see my little cursor here flying. The little white line there is a path, so you can see the zigzag I flew before. It's currently flying, I don't like to zoom out over here, to the green dot to start its path. There's its current view.
We can create 3D meshes or things along that line, but we could still do several hundred acres fairly quickly and generate topos and contour maps. We typically are doing buildings, so a lot smaller area, but being able to do that in a very rapid or short amount of time as opposed to what we can do with a laser scanner.
I'm Asha Smith. I work here at the Johnny Carson Center for Emerging Media Arts, and I run a lab here that has a working group that focuses on expanded realities, thinking about spatial storytelling and locative media. Our team comprises land use planners, placemakers, architects, engineers, community members, scholars, and artist creators. And one of our primary goals is to think about how to go beyond a digital twin of a site to create interactive stories. The extraordinary history of the missile silo, combined with its repurposed objectives, will also provide novel opportunities for engagement, education, and tourism.
My name is Brian Kelly. I'm an associate professor of architecture in the College of Architecture. And one of my research agendas is into the abandoned Atlas F Cold War missile silos, and specifically looking at the construction of them and the ways in which they had to kind of overcome some pretty major hurdles to be able to get them built. I'm using contemporary imaging technology, photogrammetry and LiDAR to then be able to document the way that they sit right now and comparing that to the way that they were intended to be built through the archival documents from the 1960s for the construction documents. So with Rogue Visual Design, we used a LiDAR to then understand exactly dimensionally what the building looked like and its exact sizing and things like that. They would use that then to, well, first of all, visualize the project, but then to be able to verify whether or not their designs fit within the existing space, and then to build a complete and accurate set of as-builts for it.
One of the main reasons why we need a facility like this is that typically if you wanted to do drilling down in Antarctica, you need to be able to test your equipment. Currently what they do is that they either drill into a really, really small test hole that they have, or else they pay to fly all the equipment up into the Arctic regions, Alaska, places like that, in order to drill into the ice there. This would allow us to design an ice column that you can kind of personalize to test new places. The way we want to design this ice column is we want to be able to have things like fresh ice or dirty ice, or maybe even drill into some water. So we can customize that ice column to be able to explore places that haven't been explored in Antarctica yet.
So the university's had a really long history of ice drilling as a result of some collaboration. It goes back into the to the 70s and 80s and 90s with Polar Ice Coring Office with the Ross Ice drilling project back through here. So this would be like the next step to sustain a lot of the prior research and technological development supporting researchers in the polar regions that would be held here at University of Nebraska to be able to continue that legacy. So University of Nebraska could stand out as a leader in ice drilling equipment technology because we could design while we're testing and really get things right. We're probably looking 3, 4, perhaps 8 years down the track if everything goes well. And the beauty of a lot of this is that it's not just the ice drilling test facility, but there's so many broader portions of this as well that come with Cold War history, the legacy of the missileers that worked in these, plus an opportunity in an education mode to use this unique facility for education, to bring climate change research to the front, to bring drilling technology, which also impacts folks here in Nebraska with irrigation wells, etc. So it's a kind of a broad opportunity to expand the university's reach with this facility and to really integrate across campus entities a single purpose here to the benefit of Nebraskans, the nation, and the world.